Good morning, everyone. My name is Ashar, and I'm going to present to you about Gen AI. Today, we are going to go through the latest revolution of Gen AI. What does it mean? We are going to look at some LLM models, GAN models, and how to optimize LLM models using few tools. So that's what we are going to do today. So this is a very exciting time for all of us in this space. I started this space about 15 years ago, and I've been never more excited than doing AI than now. So let's look at what this excitement means. So we looked at the data, and we've been an AI company for more than 10 years. And we said, okay, what do we do with this new shift in LLM models, and how do we understand what is the opportunity here? So I went to do some research. The opportunity here is $2.6 trillion to $4.4 trillion. And each human being almost, if you are in any kind of process, will be impacted about 14,000 in US. So direct or indirect impact. This is coming from McKinsey, not from us. They did a deep analysis of all these things. They said 63 business use cases. I believe it's more than that. So let's go further and understand. And this is my background. I'm Arshad Khan. I live in Irvine, California. I am an MIT Business School graduate, and I went to CISL Labs to improve my AI capabilities since I was studying it since 1995 to 2000, and I needed to upgrade. So that's me. I'm founder and chief product designer in TDM-theDevMasters. So total economic shift, is $15.7 trillion, as I said, and every one of us will be impacted, and this is targeted till 2030. We'll understand what does it mean. These are a couple of our credentials as a group. We have been top rated in multiple places. Our highest clients were GE, US Navy, couple of other big guns. Now let's look at this economical shift. What does it mean? The potential economical shift, $2.6 to $4.4 trillion, and which sections it's going to go. I was surprised to know that we were thinking that software engineering will be different, or maybe those programmers will die down. It's the other way around. The opportunity is more bigger than everything. $1.2 trillion is expected by 2025, and sales and marketing, other functions, R&D, and customer operations is $0.4 trillion. And this is all data from McKinsey. 70% of workforce theoretically has a potential to change. 50% of activity will be automated. That's what the predictions are. Now let's look at the job market in terms of generative AI. These are the four major verticals: healthcare, finance, and real estate, and edtech, which they're saying is most significantly impacted. We operate in almost three of them: healthcare, real estate, and education. Personalized learning experience will happen in education. In real estate, PropTech, which is streamlining property management, evaluations. We did that work at TDM. We have our own PropTech platform, which does evaluations for real estate, land, commercial, and residential. Healthcare, we did some work in the drug addiction process. But from the industry point of view, that's where the major shift is happening. From a job contribution point of view, AI, especially LLM models and GAN, will impact 25% more. Transformation, whoever you are, whatever you are, you may be impacted. And skill building is focused on education and training. So while doing this, since we are an AI company for last 10 years, we ask ourselves, how do we look at this new opportunity, and how do we shift our focus for using large language models and Gen AI mostly. these are the companies who are leading this. All the top guns are here. Google, Amazon, Microsoft, you name it, they all are into this leadership space. Since we do AI and data science, we ask ourselves, what's the shift in AI? And I'm going to talk a little bit more. What's the shift in data science experiments? What's the shift in natural language? What's the shift in how do you look at computer vision? How do you generate a couple of other opportunities? Biggest concerns right now is on the ethical side. A lot of governance models are coming. A lot of other ways to do ethical consideration in your design of models, in design of your systems. We did a talk at Ideas last time when I was one of the contributors on ethical side of it. I'll go more detail in further presentation. Continuous learning and soft skills. So these are the things which we have to consider shift. So the big question comes is, what is large language model? So I'm going to go a little bit technical here. So large language models are defined this way. If you look at this corpus, large language models is the blue portion, and then below that there's text generation, the outcome classification, knowledge answering, translation, dialogue, and below that layer is some of the open AI which we use it. Bloomberg has their own models, LDM, Meta, and then data centers, tools, and hosting. Now I'm going to define what does it mean for us. So large language models, LLM stands for large language model. It's an artificial intelligence trained on the massive data set. LLM can be used for a variety of tasks, including translation, writing, and generative creative work. We'll see more detail. But ChatGPT was trained on the entire internet data. It's a very popular thing to know. But if you don't know, that volume we are talking. And we'll talk further how to tune these models for our benefit as a consumer, as application developer, as an AI scientist, as a data scientist. We'll look at that. Before I go there, there's some basics concepts we are going to go through. First one is called GAN. So what is GAN? GAN is a generative adversary network. So this is now we are going how large language models are being trained and being used from the AI perspective. GAN is a machine learning model with two neural networks competing with each other in a deep learning format. This method becomes more accurate as GAN typically is an unsupervised learning. So I will explain you a little bit what is inside GAN model further. Two natural neurons make up GAN are referred as discriminator and generator, or generator or discriminator. The generator is a CNN, convolutional neural network, and discriminator is deconvolutional neural network. So we'll talk more about it. But these are like competing with each other to beat each other in in features, which I'm going to explain you. So this is how it looks inside GAN. There's one neural network which is a generator and other neural network which is a discriminator. So let's look at how they work. GAN works in a way, generative models create their own training data set while the generator is trained to produce the false data. So imagine you are the generator, or this is in simplest term described as student and teacher, what they call when you do prompting, right? Pretend or place yourself as a persona to prompt to the ChatGPT what you are asking so that it can fine tune. You will see a decoder model in coming talks, but this is how it starts with. So the GAN, which is a creator, assumes that it's going to create a fake data or something, and discriminator will try to challenge and say this is fake or not fake, and they compete with each other. So I'm going to go step explain that. So generative model creates their own training sets. It creates a random number or image, while the generator is trained to produce false data. It is a hypothetical situation. The discriminator network is it can distinguish between generator and manufactured data versus true example. That's how the DECNN is trained on. And the feedback loop is created in adversarial network conditions, and the reward or punishment method is deployed, and this is how it keeps going. The discriminator will better flag that has been artificially created. So that's the job of discriminator, to find out if this is a false data or not. For instance, a generative adversary network can be trained to create a realistic loop of an image, event face, which does not exist. And I'm going to give you a URL where you can see these people, they do not exist. But there's a website. If you create something, again, a human being, you should put it there. So this is that website. This is called thepersondonotexist.com. You can Google it. And these people are not real human beings. These are GAN model production with adversary networks. And they look more than a normal human being. All generated endless fake faces. So we see that a lot in the social media now, that, there's not a real human being, but is playing a very active role, playing a persona out of it. So this is a basic concept of what GAN models are and how generator and discriminator work. Now let's go to further one step below. What happens within LLM model? What are the science and algorithmic concept behind it? And what does ChatGPT does? One of the things I was supposed to discuss is ChatGPT. And what does Brett model does? What does T4 does? What does all these big models they do? So that concept is called encoder and decoder. I'm going to talk about encoder and decoder. How do they work? So this is how they look like. Encoder gets an input, receives, send it to decoder. Decoder can have its own input, or it can take from an encoder. So they are encoder-decoder models, they are encoder-encoder models, and they are decoder-decoder models. So we'll drill down to a basic unit of what's an encoder model. Encoder is you have feeded an input in terms of a word. So welcome to New York, and this model will convert this into a number system. If you know NLP, then it makes a vector out of all the words you've given. So that's the role of the encoder. When they are combined together in this scenario, now this vector output of welcome to New York is fed to a decoder, which will does its job and start the sequential word sequence, whatever it got from the vector input. Let's go here. Now, so based on welcome to New York, there was a vector created, decoder received it, it identified as the word one as an output, or it can feed what you call prompting, its own sentence or sequence of sentences, which we write to the ChatGPT, and it can produce the next word. So this is just to roll back quickly again. This is how inside LLM models things work. There's a concept called encoder-decoder, which will take an input in terms of text, which is a word, converts to a vector in a number form, and it will be transferred to a decoder, and decoder can take its own input or take the encoder input and go go in the forward network. Now here, the first sentence start with the sequence of words. The word one has come and it has predicted the second word. Further going, it can take the second word, let's say you prompt something in, and generate the third word. And this sequence of decoder Decoder takes from its input, generates an output, and can take. That's how you prompt ChatGPT and get narrowed down to the right query. There are challenges with ChatGPT. Does not have a lot of accurate data. Sometimes it mismatches. Those corrections can be done. I will talk further how to use it in your own ways to build your own apps or own experiment. This is a combined model of discovery decoder only, encoder only, and encoder or decoder. In this case, I have encoder and decoder. So when you can use encoder, and typical example is BERT, and decoder is ChatGPT, GPT models. So this is like a little bit technical, but what I explained will be applied here, same thing. Now, let's look at the output of encoder only and decoder only. So encoder models are, you can like fill in the blank, like fill the missing words. That can be one output. Sentence or document classification. Third is NDR, if you guys know, name entity recognition, which person or an organization, this kind of things. It's an apple or orange, this kind of thing. And then Q&A, question and answer. This is encoder model, give passage and question, and you can get the messages out of it. Decoder example is ChatGPT. It's very simple. It does few things: text generation, conditional text generation, summarization, and fine tuning. So as you give, as I said before, decoder takes one word and it will predict the next word. The word 2 can be an input to word 3, the way you interact with ChatGPT. So ChatGPT is decoder model. For further, you can a little bit drill down into it. The good news is this is evolving so fast that now, if you guys are aware about Hugging Faces is the open source community where all these models, including and algorithms, are placed there. And they also have some corporate and paid versions, but you can get a lot of benefit out of it. So we use Hugging Faces a lot to do the work. Here, I wanted to talk to you if you're a data scientist or an machine learning engineer. How does your life changes after having LLM models? So in LLM, in your experiment, you might have done the basic things. For example, bringing the data, doing the machine learning model, deploying and managing, and then adoption. That's all standard, right? And data prep, cleaning. From there, you went to experimental mode, monitoring, optimization, how your model is working. This is the new portion. The bottom one is this framework is new. So not only you can do an experiment, but also like what we were doing sentimental analysis before, now you can do through large language models. So how do we take a large language model like ChatGPT or BERT and tune down to our experiment? So for example, you're doing an experiment in data science about cancer prediction. And you predicted a guy has a cancer or not a cancer or intermediate state, and you want to know what are the failings at that point, what are the food habits you have to change and all that thing, and you want to tap into something like ChatGPT to attach to your experiment. That's where you'll design something like this. And I'm going to go a little bit further to explain you what it is. So prompt engineering is here, selective GAN test prompt iterations at the bottom of it. Choose the model domain and prompt the database. It's very raw. You don't go into database, you go into large language models, but it's from a high level point of view. So we'll see how this works now, next step. So next steps for you is something called transfer learning, which you will, whatever experiment you've done, you will transfer your weight management in either neural network or some layers to the LLM models. So pre-adopted, pre-trained models and new domain task is defined. Fine-tuning the model updates an existing model with new data for new tasks. And then, of course, you have to take safeguards and ethical consideration, ensure the model is safe, ethical, trustworthy, and distillation. Now, train or create much smaller models. So we will look at LangChain, which help us to do this. But these are the steps how you go through this process. Much smaller models, similar performance downstream, task capability by using the student-teacher philosophy, encoder, decoder, or generator adversar kind of a thing. Few shots approach and much smaller model. You can tune the model to your use. You can literally drill down to what you exactly want out of that whole large language model. So how do we take LLM significantly smaller portion? That's the next challenge. And as I said in the beginning, every organization, every corporation, every experiment will be impacted. And so these are some high-level steps how to do it. If you are going to integrate multiple large language models, not only one, you can do one or multiple. You have image and text, you have voice and video, you can do multiple combination. So these are the steps you're going to go through. Tuning. This involves removing of unimportant weight of the neural network and LLM. So reduce the noise, basically, what you don't want. And then quantization is involved reducing the precision of weight and activation. If you know neural network, these terms might be a little bit easy. Activation functions and weight management. Knowledge distillation, this involves training a small model into mimic, which that's our goal. Low ranking factor, drop the noise, autofit, decompose matrix, and compact embedding. This involves reducing the dimensionality to output an embedded LLM model. Architectural change involves the architect of LLM model to be more efficient and also integrated with your bigger experiment, which I showed before, and parameter sharing. This involves sharing of parameter between two part of the transfer learning. As I said, GAN models, they behave like a teacher and a student. Processes are this: train the large language LLM to be a teacher on the large corpus, which is entire internet in ChatGPT world. Generate synthetic example using a teacher model. So a hypothetical number or a fake face or someone which does not exist, you throw that. That's what it's saying. With either sampling or model distribution using specific prompt. So when you prompt to ChatGPT, you guys know you can ask very hypothetical things there. Train the small LLM student model to a small number of labels example along with the synthetic example generated. I'm going to also show you how we generate synthetic data and an example of it. It's never exciting as we were so exciting. It was never exciting as now it is than past. We started doing experiments, and the biggest question is, do you have enough data? And sometimes we do, and sometimes we don't. So now those limits are gone, and I'm going to show you how. That's on the synthetic data side. Fine-tune the student model to a smaller validation, set the optimize the performance. That's the how to reduce it. So to do all these functions, there's a library called LangChain, which is one thing. If you're starting in LangChain, you have to do paper upgrade after every 4 hours. The community is building this thing every day. There's a new release. So just make sure that if you're writing those experiments, you have the latest out of the model. So chain of thoughts, build a smarter AI with LangChain. This is a open source package which you can pip install in your experiment. And what does LangChain does? LangChain provides a framework for chaining multiple large language models together to build more advanced AI. As I said, you can combine multiple models. Rather than relying on a single model, LangChain lets to combine different models with complementary strength. So you can combine image with voice, video with text, those kind of things, text with video, cross functions. So LangChain handles the interaction between these models, allow them to build on top of each other. Not on top of each other, on each other, sorry. Some real-world examples are conversational AI, chain a GPT model with a Cloudy model. If you are using ChatGPT, there's another GPT is called Cloudy, so you can combine them. Document summarization, generate a summary with GPT, verify the accuracy with Cloudy. Code generator, codex for synthetically wild code for GPT, natural language description. So co-piloting, what we call now. So those things are some examples. You can co-pilot using some of the functions in LangChain too. Why LangChain matters? Obviously, data aware, connect large language model to drive data source richer and responsive. It's a agentic way, enable models to adapt to interact with each other environment. Modularity, offers component-based structure, flexible stage, pre-built chains are there, simplify setup ready to chain. You can use other people chains and consume it and find a fast way to do it. Persistence, memory, it retains the memory. One of the things ChatGPT is not good at it, possibly the 4.1 might be, I haven't tested it. You have to redo a couple of steps, and sometimes when you do 1, 2, 3, 4 step and you thought the second step was not, and I'm going to go and modify the prompt of the second step, sometimes the output is not accurate or way off. So all these problems can be addressed through LangChain because it can retain the memory. It gives you control how to fine-tune and tune your large language model for your own experiment. And it gives you in a very simplified way where you can literally program in Python and control those parameters. So there are a couple of more strong architectures. Lemma indexing is one of them, which go more deeper. LangChain, like a ChatGPT model 3.5. I haven't covered lemma indexing, but you can look up more details about it here. So LangChain model and flexibility of architecture. These are the I/O, data connect, chain and agent and memory callback. It's a summary of what we talked here. You can drill down to a level where you can customize your own GPT for your own business and own application. And that's what we specialize into now. Last section this is very exciting for me. Ran into multiple problems when we started doing small data AI. Right now we have a platform which does makeup for women, and you can imagine variant of makeups. No matter how much we bring from internet or the Sephora's and all those things, it's always someone can put the things in a different way. So generate synthetic data is one. So we have generator and discriminator. This is a noise which I feed it here, which is totally false, and the output is something like this synthetic output, which is a combination of these two neural networks and give from original to synthetic data like this in a very simplified way. Now, I have talked about GAN, so it's mostly a repeat of it's an unsupervised. It has a generator and discriminator, and synthetic image can be generated. We did an experiment. This human being does not exist, and we were able to, from nowhere, in a vector format to a real human being. But this human being does not exist. We were able to experiment this. That's pretty much it from my side. Couple of things we do. We have some of our own offerings in generative AI and data science, and I'm ready for Q&A.
Yeah, I just gotta say, I really like the entire presentation. That website where it was this person does not exist was so amazing. Like they look really real, even more real than my pictures. It's kind of scary.
Yeah.
Or we come.
Yeah. It's amazing, and it solves a lot of problems. Like a positive side is like, as I was saying, we do small data sometime and run into those kind of problems, especially which I'm working on right now is a makeup app. So it takes a human being and generate 1,000 ways to do the makeup, which OpenAI can capture and train itself into. So that's a real example we are doing it.
I love that. Maybe a question here is there any technologies? I'm assuming as time goes on, this will only get better, and will there be any sort of technology to see what's real, what's not real, to distinguish what's AI, what's not AI? Because I've seen so many videos produced of like people, and even images of people, right?
Yeah, so I'm not approaching this problem, and this is not me, the big guns, is we call something XAI. So whatever steps your neural network is doing, you put an auditor through that process, which is an ethical consideration. So to get a direct output of this face look like a human being or not is a little bit challenging. But if you look at the trail, how this image or this voice or video was created, that trail tells you it's a fake or not fake. So soon, I'm assuming, I haven't done any research on it. As you run your neural networks deeper and deeper, something like IBM has deployed this in Watson. XAI is an index which will track all the actions like an auditor and will be able to present how did you come up with these results. So that's what we are doing internally to make sure that we have a trail of what AI we are doing, how we are taking a snapshot of every run and every output and save it as a repository.
I like that. Okay, we have a question from Dell. Go for it, Dell.
This is Dorothy. Hi, Dorothy Lucy, and I am curious about your makeup adventure. It sounds really interesting, and thank you for a very elaborate presentation. It was really clear and concise also about what is happening. I'm curious how you are working with that concept of makeup on different faces, because there's so many variables.
Yes.
I mean, you kind of addressed it already, but I'm like thinking, oh my God, you have color, you have size of faces and eyes, and then you have texture. So how are you incorporating all these variables together?
Yeah. So the project was started in 2020, and that time GAN was not available, like generative facial. So we went to Sephora and a couple of companies. That's what this app does. It's called Data in Hub. It's still in the build process, but there's prototype available. So our job was in the beginning as an AI company to take a face, identify cheek, eyelids, lips, and recommend a product to get the same look. That's what we were doing. Now, the exciting part was our accuracy. If we have trained you on the data, right? and how many variants. So that's where this generative AI is helping us now. So we are, for example, feeding like my face as a man with the makeup, and it will create millions of variants, and eventually the generator knows I'm giving false Arshad with the false makeup, and discriminator will know this face does not look like a woman face or this makeup. So they challenge with each other, and during this process, they generate a lot of data. So when an open CV picks up check, all it does from the AI perspective is do a proper extract of the feature of the face and then match with what product is available. But that's one side of the platform. The other side, what I was talking is, it solved my biggest problem, is to have millions of faces and train on. So it does go, and let's say we upload some very famous actor face, and it would show to get this look. These are what we say.
So
Makes sense?
it makes sense. So what you're doing is you're working in reverse. You're saying this is, the ultimate look is